Did you hack Teams?
What do you
say? You hack Teams?
Hack Teams.
Did you hack Teams?
What happened?
I don't know, but that's what he said.
Who?
Didn't you?
Why did I hack Teams? I don't understand. All right.
I had a question about like bools internally because they are apparently uint 8. Mm-hmm. Why not just bools?
Well, what type is a bool? What's the size of a bool?
I'm assuming it's 1 bit. That's always what I thought.
Nope, it's 1 byte.
Oh.
Yeah, bools are 1 byte. They are just glorified integers. Or glorified shards. Really.
What are the other bits ever used for?
Well, nothing. I mean, the if bool, all it checks is if it's 0 or not.
Right.
So if a bool that's like 10, it will still be true because it's just not 0. So
I'm assuming why that is that you can't save just a single bit on memory. You have to allocate a full byte.
Yes. Because memory addresses only come in chunks of 8, right? So you cannot. It's stored as megabytes. It's stored as megabits. So that means you cannot address any singular bit in memory. You can only address them 1 byte at a time, right? A memory address will point to 1 byte. So if you had 1 bit in there in the class, all of a sudden all the other variables would be 1 bit offset from that byte alignment. So that means it would be a pain in the ass to actually reference those other things. So yeah, so that's why the smallest thing you can have is 1 bit.
Oh, that makes sense.
Oh, sorry, the smallest thing you can have is 1 byte. So yeah, good question.
Could you just take a fast look at the game mode base class or game mode class?
Which simple
player slash some fuck player. I think I screwed up that include somehow.
Well, what file?
Yeah, because my character is not under player.
Your character is not under player?
Yeah, in this CPP game mode class. I am wait. Why is it player slash?
Oh, that's because when I made the file, I made a new folder.
Oh, okay.
Called player.
Okay, so I shouldn't have to do that. Okay, then it's nothing, I guess.
Yeah, so I just made a folder called player, so that's why.
Then I understand.
All right. You guys feeling ready to move sideways? You guys fucking ready for this?
Oh yeah.
All right.
I've been waiting to move sideways all day.
That's true. As humans, we go sideways relatively seldom. I mean, I've never strafed. It's not I should strafe move into the bus. That never happens. We always turn and then just go forward. So, well, maybe we don't need strafe. All right, so I'll do a move right then. And the reason I'm not calling it the reason I'm not calling it strafe is because it's just a bit of a Freudian slip there. The reason I don't call it strafe is because it has a 1 and a -1 sort of directionality to it, right? The axis goes from 1 to -1. And if by calling it move right, I'm sort of putting meaning into that value. I'm putting the meaning that 1 means we're moving right, and -1 means we're moving the opposite of right, so we're moving left. So that's just a nice little naming convention that I like, that you don't do move horizontal or strafe, because then it's sort of, okay, is that right or left? It's kind of up to debate, right? Well, but we move right, there's no question what that is. So I'll just do D is 1, and I'll do A is -1. And then I'll also, because, yeah, let's just do the gamepad as well, because why not? So I'll just do, let's see. Oh, no, wow, that's wrong. I'll add another axis, and that's going to be like that. Left thumb 6 x axis. Great. Cool. So now let's just go in and bind that bad boy. Excuse me. So we'll do fuck player. Oh, right, because I haven't remade the project, I have to. Okay, well, whatever. I'll have to just browse it manually. So here, we'll instead of move forward, then we'll do move right. And then here we'll do handle move right. So I'll just make a new function, very similar to move forward, but instead it will just be move right. Create that declaration, baby. And then we will add movement input, but instead of adding movement input in the X direction, where should we add input? Any guesses?
Y direction.
Why?
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 Because what is up?
Why? No.
No,
Says-
how dare
Why?
you? No,
Why
wrong,
is still
wrong
up?
answer, you lost. Okay, so compile. You get no money. We actually tried, I remember when we started making It Takes Two, it was one programmer who went on a journey to convert Unreal Engine to Y up, but it didn't work. It was unfortunately too hard-coded that it's not possible.
Tragedy for the ages.
Yeah, exactly. So now, hopefully, if I hit A and D, yes, we are strafing. So now we can move in a circle. Fantastic. And if I use the gamepad, then hopefully that will also work. Yes, I can move in a circle. Great. So, what about what about looking? So we wanna look. So with that, we want to actually add an axis, right? Because we want to move with the X and Y axis of the mouse. And in the engine, this is kind of like a little bit of magic, but in the engine that's defined as an axis. So mouse X and mouse Y are defined as axis inputs. So I'm gonna make a new axis mapping. So I'm gonna do look right. So I'll define that as mouse X. I don't think you can do that actually. I'll have to go in here and do mouse X. There we go. So here I'm defining a can I do XY? What's that? Can you have 2D now? Oh, it looks like you can. Huh. I guess maybe you can have 2D axes. That's cool.
How do you even handle that? Like, if you only get one float input?
I'm guessing it's like another bind. So I'll do a player input component. Oops. Binds. There, bind vector axis. Oh, cool. Oh, I didn't know.
Nice.
Very neat. We're not going to be using that. So yeah, mouse X is going to be look right. So let's bind that up then to a delegate. So I will bind look right. So I'll do handle look right. And I'm actually not quite sure what it's going to look like. So let's print from this to see what is the value even. So I will just do log temp, log, and then mouse inputs is F. I think it's gonna be the delta, but I'm actually not quite sure. Let's take a look. It's always good to test. Look right, yeah. Okay, so everything looks good. Compile. Cool. Let's see. So it's 0, and if I hold left... Okay, so it's not the delta. I actually think the mouse x-axis is not the delta axis. It's actually sort of bound as a velocity. So it's like it's defining what's like the one velocity of the mouse, and then it's just mapping the mouse to be that. So if I'm like trying to pull it right at like a stable state, then I get 1, and if I do it the other way, I get like -1 or something. So I think it is actually not giving us the delta. It is giving us sort of the the velocity normalized. So that's okay. That's weird and magical, but okay, fair enough. I guess that's useful. And the way we map that into turning is that we do add controller yaw input. All right, so we have these functions here, this function group called add controller x input. So we have add controller pitch input, we have add controller roll input, and we have add controller pitch input. I think I said that weirdly, but we have each of them. So we have pitch, yaw, and roll. The Euler angles at least, that is. So we can like weird sounds from my wall. It's like a mouse or something. That's scary. All right, so we can add an input to roll the controller, and in the controller, in that it's kind of weird what it mean like controller add roll input. Is kind of weird. Don't worry about it too much for now. We might look at it later. Later will make more sense, but you can see it as we are rotating the pawn. So we're rotating the pawn in yaw and in pitch and in roll. And which one do we want now for turning left and right? Which axis are we rotating around?
If it's left and right, it should be yaw.
Should be yaw, right? And if we want to look up and down, which axis is that?
Pitch.
Yes. Have you guys used quaternions? Anything?
Slightly in my tool.
We've used them, but I don't think any of us is really comfortable with what they are. Is that fair to say, guys?
What are you?
Sort of.
I remember feeling my third eye opening when I started realizing it was like a 4-dimensional sphere, but I didn't get past that.
Yeah.
Yeah.
Yeah. Going that way is dangerous.
4D unit hypersphere, I believe is
Hypersphere.
Well, it's a point on the unit hypersphere that we use for rotation. Yeah, but what that means, I don't fucking know.
I just like to see them as an axis and an angle. I think that's when I realized that I was like, oh, this is fucking easy. It's fucking baby toy. It's all axis and angles. Anyway, that's off topic. I was just curious since we were talking about the unit angles here. Anyway, so I'm gonna do handle look right is just gonna feed its input into this add controller yaw input here. Great. So let's see what happens. So I'm gonna compile. Let's play. Oh, it works. Great. Little jump scare for you. So okay, so we can look right and left. So now we're kind of in Doom, right? We can like turn, but we can look up and down. So that's cool. But at least it works. So that's neat. So let's now do pitching then. So we want to be able to look up and down as well, because we're not in 1993 anymore. So I'm going to do look up. And that's going to be mouse Y. Like so. And then I will bind that. So we'll do look up. And that's going to be handle look up. Gonna make the function. Gonna declare it. And then instead of add control yaw input, once again, what we'd write.
Pitch.
Yes. Like so.
I
And-
think it should be negative unless you want inverted controls.
Ooh, nice catch. Because right now, if I move the mouse upwards, I haven't compiled, so nothing happens. Obviously, that's what I meant to say. Okay, now. So we play. And, oh no. Inverted Y. Yeah, so inverted Y, unfortunately. So yes, one thing we can do is go in and add minus here. But since we're fucking intellectuals, we can just go into the project settings here, into input settings, and we can set a -1 scale on the y-axis. So we're gonna take the input and it's gonna invert it, so that look up actually gives the value up instead of it look up giving it the value down. so we get the correct value out of this this input here. So we're sort of tweaking the input to be correct. Oh, there we go. So now we can look up and down, left and right. And of course, if I move forwards, we're gonna move forwards, right?
Nope, it's the
Leading
Lexus
question.
aligned.
Oh no! Oh
World
shit!
space.
Oh,
Hey.
Yay for world space.
yay. So okay, so why is this happening? Can someone explain to me more than the word world space?
Well, you're
You move you set your thing to go on the x-axis in the worlds, or with forwards and backwards. It's not relative to your own position.
Exactly.
Relative to your, fucking look. Whatever, however you
Your
say
fucking
that.
look.
Yes.
that's a technical term, I believe.
You're basically like, if this was seen from a bird's eye view with a grid, it might have made sense. But now it's not. It doesn't take first person into account.
Exactly, because what direction do I want to move in when I'm pressing
That one.
W?
The forward of the player.
The forward of the player, exactly. Very good, very good. Good catch. So what we'll do, instead of hard coding X here, so this will move along the X-axis of the world. Rather, we want to move in the actor's forward direction. So what we can do is that we can use this neat little function called getActorForwardVector times value. So now I'm just taking the actor's forward vector, I'm just scaling that by the value of the input. Very nice. And then for move right, what should I type here? Any guesses?
right vector
Right vector times anything?
value.
Yeah, there you go. Get actor right vector times value.
And surely we have to multiply this by something, right? Because we're just moving 1 unit per whatever in some direction. There's no speed here.
You would think so if you were a Unity developer, but of course, add movement input is magic inside of a pawn. Who the fuck knows what's going on in there? So in Unreal, when we're using pawns, the pawn has like a speed variable tied to it. So the pawn actually controls the speed.
That's doing our speed and our delta time for us?
Yes, it's doing everything like that. And all add movement input does is just set what the input is. And then on the pawn's tick, it will actually look at the input and add acceleration and all of that stuff. So yeah, it's a good thought. That should always be the first thought. Should I multiply by delta time? Like, what's the unit here? And so it's good that you have that sort of reflex. However, in this case, we don't need to, because it's magic. So let's compile. Let's play. Wow! Wow! And we can jump, so I can go up on this. Holy fuck! I can jump to this. It's very floaty right now, but it's okay.
Can you still double jump?
Yes, so I can.
Oh yeah!
It's like an
Try to
actual
land
game.
on the flying cube.
I can like fucking balance on this thing. I can jump on this boy. See if I can do that. It's gonna freak out when I'm standing on him. Come here.
Oh Jesus!
Oh, so fucking good!
Nailed it!
Hey!
That is
Easy
amazing.
as a pizza pie, and it's like it's like freaking out because it's like keep colliding with me.
Oh,
Alright,
so
cool.
it like kind of parents you to a moving object if you stand on it.
I don't think it parents you, but it definitely takes that into account. So it's like it's standing on something, so then it will start going into like a move with mode where it will add the delta of the thing to ourselves before we actually start moving. So we will be moving sort of relative to that surface. I'm guessing that's how it works. At least that's how I would do it.
I know in Unity, because I did this way like years ago with a moving ramp. Basically, you went into the rigid body of the moving object, and then basically copy pasted like the velocity onto yourself, so you had a matching velocity at all times, just to make sure you didn't get any weird parenting issues.
Yeah, you wouldn't parent because that's kind of scary.
Yeah.
Yeah.
Very fun when the ramp then rotates and the player's on it and then jumps off. They're still rotating.
Yeah, you're gonna be in a world of hurt. I did that once at It Takes Two, and it was the most horrible bugs ever came from that. So I learned my lesson to parent.
One of the level designers made that bit of code, and we didn't realize it until it was too late.
Yeah, level designers, they don't know they should be afraid. They like scale something with a negative value, and they're like, yeah, this is fine. And it's like, are you crazy? Like, aren't you scared? And they're like, no, it's fine. It's like, no, it's not fine.
To his credit, though, he wanted to be a programmer, but the what's it called? The organization of that project was in the fucking pits from the very start.
Yeah, well, I mean, it's fucking future games, though. I want actually more air control. I wanna make like a cool FPS game, so I'm gonna add some air control to this. Add some ad control.
Playing Tribes now?
Sorry?
We're playing Tribes now?
Yeah, bro. I'm gonna make Tribes. So I think it's like air control something. There, air control is just a floating point. So we'll just do 0 is no control, 1 is full control at max speed of max walk speed. Okay, cool. That means nothing to me, but I will set
Make
it 1.
it 2.
2?
Yeah, like you have more control when you're in the air.
I see no problem with this. Well, it's actually not that. I thought I was gonna be more control.
Assuming it's clamped.
Yeah.
Yeah, I mean, I'm assuming it's clamped to 1, but even then I thought like 1 was gonna be like I'm on the ground, but okay, well, I guess this will do. This is like, you know, when you're working with the Unreal Movement components, like, oh, it's obviously gonna work like this, right? And it's like, it doesn't. And you're scared. So I can still balance on this thing. Oh, fuck. Alright, cool. That's our character. So we did it. We made it. It's very cool. Let's make... I'm wondering if we should make a gun. You guys want to make a gun?
Hell yes.
Okay, let's make a gun.
Oh yeah.
So I was thinking, yeah, let's do it so we can like shoot stuff with like pew pew pew. We can shoot like projectiles. So I think, yeah, let's first do it simple, like no gun, like it's like, I guess it's like a Quake or something, where it's like we don't see a gun, we just shoot rails, or shoot like some sort of little ball thing. So first of all, we wanna define. Okay, so we want to spawn something, right? We want to do like, when I hit left click, we spawn like an actor or something. That's going to be our projectile. So we spawn something it's supposed to fly through the world. So how do we spawn something? Well, to spawn something from code, we'd first have to have a reference of what objects or what class are we actually spawning. You remember in the game mode, they needed reference to the classes to spawn. And you know, it's sort of the same thing now, where we need the reference to the actual bullet to be able to spawn it. It's like in Unity, where you have like a game object reference that's, you know, pointing to a prefab. That's sort of what we're gonna do as well. I'm looking at it like the screen space reflections over here, where it's like the reflections go away when they're on the screen and come back. Screen space reflections are like weird. All right. Anyways. So what we'll do is I'll make a projectile class in C++. So I will just go in and add like a fuck projectile .h, and I'll make a fuck projectile.cpp. Like so. Open those up. Okay, so I will pragma once. So if I want to inherit from actor, what do I type here? What should I type after class?
The name of
A.
your class.
A?
And then what? Oh, what Ewan said?
What do you say?
Yeah, your own class name first.
Okay, what should it be called?
Gun?
Gun?
Oh, projectile. Never mind.
Fuck projectile, right?
Yeah.
Good.
And then what do I inherit from?
A actor.
Just like this? Is that all I type?
No, public.
Yes, public, because this is C++ and we hate it. We hate ourselves. There we go. Whoops. All right, and where do I include actor from? What's the include path?
game framework actor.
Yes. Game framework actor. Whoops. Like so. And I guess that's it. We're done, or are we missing something?
The U class.
In class.
And the generated.
Generate body.
Very generated body. Very good. And that's it, right?
As well as the include generated.h.
Oh, what is it called?
I have no idea.
Does anyone remember? What should
Isn't it like include fuckprojectile.generated.h?
Yes.
Like that.
Oh yeah.
Exactly. Fuckprojectile.generated.h. Same file name as the actual header.
And you're gonna need parentheses after U class.
Yes,
Right?
good catch. All right, fantastic. So now we made a reactor. Very good. So let's say I want to add a static mesh to be its root component. What would I type here in public?
Use static mesh. And then forward declare it, I'm assuming.
Just use static mesh like this.
Oh, it's component as well.
Very good.
Oh, right.
Good catch. All right, and yeah, that's a good idea. Let's forward declare it. So we'll do that. And that's it. We're done, right? Is that all we need to type?
Want to make it into a? Do we want to make it into a U property?
I don't know. Do we?
We should.
Yes.
And what do we want? Why do we want to make it a U property? Is there some specific thing we want to happen?
To open it up so the also Unreal knows that it's supposed to exist.
Very good. Very good. I would say that's a very good idea.
And then editable anywhere.
Visible
called?
anywhere, right?
Edit anywhere is a good guess. That's close. But visible anywhere is what you generally do for components because you don't want to edit. It seems weird because edit with anywhere seems like you can like edit like the variables of the component. But actually editing a component variable means that you can set the variable to be whatever you want. So that's kind of a catch where you think it's supposed to be edit anywhere, and I've fallen for that a billion times. But it's actually supposed to be visible anywhere. But
Wasn't that the one that you can only see the field, but you can't edit it? Or was that another one?
exactly. So visible means you can see the field, but you cannot edit it. So if it was a float, it would be like a constant float. The thing with components is that the component will be visible, and that means you can also edit what's in the component. So you can set the static mesh component to be you can set the static mesh, you can set the collision and stuff. But the difference is the variable itself is not editable. We cannot set the mesh variable to anything. Because that's what we want. We don't want people to go in and like change what the actual component variable is to point to another component. Like we don't want that. And that's what edit anywhere will do. So you can change the actual mesh variable. So that's why we keep those as visible anywhere.
Right.
Very good. So if I want to add this component, is there any other function I should be declaring?
Constructor probably.
Very good. So I'll make that. And let's include the header. Whoops. Projectile. There we go. And what do I type here? What do I do?
Mesh equals add default subobject.
Default subobject.
I think.
Create default subject.
Yes, there you go.
Oh,
Create
right.
default subject. Very close. Very close. And that's it. Nothing else.
Like the crocodile things.
Yes. And what do I type in here?
Static mesh component.
Yes. And then what do I type in here in the parentheses?
Text and
mesh,
then
maybe?
yeah. So the name of the object, I guess, right?
Exactly. Let's just call it mesh.
Do we need to include the static mesh component in the CPP file now, seeing how we're actually using it?
Yes, that would be a great idea. So let's include it. And what's the include path? Who's the first to find the include path of static mesh components? Go, 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 go!
While everybody's searching, I can ask you, when you search for things, like the window that you pop up, what is the quick command for that? Shift
Alt O. Shift Alt O. So O for open.
Right. Thank you.
I don't know what the header file is called, but it's under engine classes component static mesh component.h.
Can you repeat that again?
Engine classes components static mesh component.h.
Ah, very good. So what will the include path be if it's in engine classes components?
I'm assuming component slash static mesh component.h.
Yes, exactly. Classes is the root path. So that means we can ignore everything from classes and before that. So it will just be components dot static mesh components.h. Very good. Very good find.
Cool.
And are we done? Or something else we should do maybe?
Set root object maybe?
The root component. Exactly.
Yeah, it's a root component, yes.
Very good. We made our very own actor on our own. Very cool. So that's great. So that's now we've done that. It's always good to refresh. So now we can probably place this here if I compile. Maybe it will even actually compile. Wouldn't that be something? Ah, fantastic. So I can probably do fuck projectile here. Yeah, there it is. Great. Woo! Cool. So we probably want to have some mesh to sort of go along with this. So it actually has some sort of, something. So I will actually override this in Blueprint. So we can set up the mesh to be a default thing easily. We could use the constructor helpers if we really wanted to, but I know I showed it once. I don't really want to do it again. I don't think it's a very good thing to do. So I'm actually going to make a folder here that's called blueprints. It's always good to do. So we have like a folder for all our blueprint overrides. And does anyone remember how we would override the fuck projectile as a blueprint? Do you guys remember? It was quite a while ago, so it's okay if you don't remember.
When you create the blueprint, you can select the CPP class, CPP file that we made, and have it during the all classes. If you search for fuck projectile,
yes,
you can select that one there.
Very good, very good. And we call that BP underscore fuck, I guess. Fuck projectile. Cool. So let's open it up, and then we have our mesh here, so we can set that to be a sphere or something. And so let's do a cone, so it's like a little bit of a... Yeah, there we go, so we'll do a cone. Very cool. So that's our little projectile. So now if I place this in here... Oh, let's remove this. Place this in here, there we have our little projectile. Very neat. So, how do we make it move? Well, we could just write our own sort of movement code if we wanted to. We could, however, use a component in Unreal, kind of like the character movement component. Unreal also has a very neat projectile movement. So that's another component we could use. So I will say this is something called an actor component. You might see it's not in. There's like a little line here, so it's not like attached to the mesh. It's actually down here, its own separate list. And this is called an actor component, and that's a component that's further down in the inheritance chain than the scene component. So the scene component inherits from the actor component. And the actor component doesn't have a transform. It has no concept of being attached. It is only just pure data and tick, essentially. So while it can affect the actor, of course, it can move. In this case, the projectile movement will move the actor, so it will act as a projectile. But it is not attached to anything. It doesn't have a sense of position in the world. So that's the difference between a scene component. A scene component is something that can be in the world. It has a position, it can be attached to other scene components. And an actor component, it's something that's just on the actor, kind of like a Unity component, right? A Unity component doesn't have a position or anything, it's just on a game object. And just like that, an actor component is just on an actor. So that's why a projectile movement is an actor component. That's why it's in a separate list here.
So will it then move all like the objects in the hierarchy in the same way?
It will move the root component. So this
Okay.
projectile movement is specifically set up to move the root component. So it will move the mesh, or in that way, it will move the actor, since the actor position is just the root component.
Cool.
So let's try it out and see what happens. So I will just do that, and let's see what happens. Okay, so let's simulate instead, so I can so I don't like teleport away. So I will simulate. Okay, so that's cool. Not a super cool projectile, but okay. I guess that's something. So let's see what kind of stuff it has in here. It says initial speed. So initial speed of projectile. If greater than 0, this will override the initial velocity value instead of trees velocity as a direction. Yes. I think there's an initial velocity as well, is there not? Let's Google it. Oh, here, velocity. Okay, so here's the velocity vector. So it had 1 in x. What if we type 500 maybe in the x instead? What happens then? Whoa! Okay, there it went. So that's the x direction. Is that the local x direction? It seems so, yeah. So let's wait if I rotate it like this and then I simulate. Ah, okay, there it goes. So it flies away in a little nice arc and then just lands on the ground. And that's it. Okay, so that's pretty neat. So what happens with the projectile movement is the moment that the actor is active, or like the moment it spawns, it will just start moving in this velocity direction. But as the initial speed set here, if greater than 0, this will override the initial velocity value and instead treat velocity as a direction. So we'll treat the velocity as a direction. So what we can do is, in this case, we might want the cone to actually point in the direction we want to go. And as you can, I cannot rotate this cone. I can't scale. I can scale it. I'm not quite sure why I can't scale it, but I cannot move it and I cannot rotate it. And that's because it's the root component of the mesh. And remember, the root component, that's the position and the rotation of the root component is the position and rotation of the actor. So that's why it doesn't really make sense to be able to move the root component in the blueprint editor. Because in the end, like, that's where the actor is supposed to be. What if I move it here? Will it just move the actor, or what does that mean? So that's why you cannot move or change the root component at all. So ideally, maybe we would have made like a scene component be the roots, and then like add the mesh later, and then rotate the mesh to point in X direction. Actually, let's do that. Let's instead of a mesh. Whoops. Let's instead of a mesh, let's just have a sphere component be. So let's like the collision is just a sphere, and then the mesh is just gonna be something visual. So I'm just gonna add another component. It's gonna be a sphere component. So again, that is just a sphere collider, and that's it. And I will create it. Oops. Sphere, like that. And then instead of the mesh being the root component, I'm gonna make the sphere the root component. And then what function did I have to call on the mesh to make sure that it's attached to the sphere? Do you guys remember? Which function did I call?
Something setup, right?
Something setup. Good. If I go into setup, I can actually
setup attachment, maybe?
Yes, and then I find this setup attachment here, so that's probably right. So yeah, good. So setup attachment, and I give the parent, and the parent is gonna be the root component. I can also type sphere, they're the same thing, so I can just type whichever. Nice. So now we made a sphere to be our root components. And then we made the mesh to be just attached to the sphere so we can move it around, rotate it around, and so on, and scale it up and down.
So that's similar to like parenting stuff under each other in Unity, I guess.
Yes, exactly.
Okay,
So then you
cool.
make like the projectile be like the root game object, and then you make like a mesh game object attached to that.
Yeah, makes sense.
Yes. So,
Do we need to include the sphere component separately in the CPP file?
we might have to. Let's see what happens if we compile. It's a little bit like, I don't know. It's like sometimes it's included, and it's like, I don't know why, but I guess that's cool.
Looks like we have to.
Yes. What? How should we interpret this error here? At line 15, it is like missing type specifier, unexpected tokens proceeding. How should we interpret that error message? Here's line.
We
15.
need to either forward declare something or include something.
Yes. What should we do in this case?
Looks like useSphere. Wait, line 15.
Yeah.
useSphere component needs to be forward declared, and it's not.
Why should we forward declare?
Because it's a pointer, so we don't need the full type. We just need to know that it exists.
Yes. And why is it better to forward declare than to include in the header?
Because it keeps your compile times down,
Yes.
and it stops circular references.
Very good. So I will forward declare use for components. And then in here I should include it. And what's the include path? Go, 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 go!
Components, components, and then sphere components.
Very good. Components, sphere components. Here we go. Sweet. So now if we compile, it should work, or it breaks and we have to restart. It could also happen. You never know. Especially stuff like changing component ordering is usually what breaks what breaks everything. Oh yeah, so now we can see, okay, so now we have a sphere here. Great. And the mesh is parented to the sphere. So now we would be able to like scale this down, and we can rotate it a little bit. And like scale it up a little bit so it matches the... Actually, let's make the radius of this sphere a little bit smaller. I'm just showing that it's totally fine to change these things in editor. Like, you don't need to do all of these changes in code if you don't want to. Like, sometimes it's better, sometimes it's not. I turned off snapping of the position here so I can position it a little bit better. But yeah, here's snapping for the translation. And here you can set the snap size, so you can snap to 1 unit, or you can snap to 5, or you can snap to, 10,000. Whoa! That's... it's gonna be like... Woo! So yeah, pretty big snaps. Yeah, so it's a snap value. But yeah, I would usually... Stuff like aligning meshes and setting the sphere size and stuff like that, I would usually do in blueprints, because it's, much easier to see what you're doing instead of like hard coding position values into code and then like recompiling and hoping it works. So that's usually how I do things. There we go. So now we will move with the sphere instead of moving with the mesh. The sphere is the root component, that's what will be moved. So now if we play... Then the X is the forward, so we're sort of preserving that sort of like forward vectorness. So I'm pointing this to be pointing in the X direction to make sure that X is always forward. And then in a projectile movement now, I will set velocity to be 1. So I will say it will move in the X direction. So X would be the directionality of the velocity of the speed. And then I'll change speed, this initial speed, to be how fast we're supposed to be going. So let's say at 1,500.
I'm a little bit confused by the sphere. Is that just like an empty, but also has the functionality of being the collider, I guess?
It's only a collider.
Right, but you made it a sphere so you could rotate it and scale it, right?
I made a sphere so I can attach the mesh so that I can move and scale the mesh. That's why.
Right, because the mesh doesn't have any scale and rotation.
It doesn't if it's the root component.
Okay, But
right
now
now
the sphere is the root component.
yes. So now I cannot move and scale the sphere. But the sphere has the
Oh.
sphere radius, so I can change still the radius
Right,
without worrying
yeah.
about that.
Okay,
So-
then that makes sense.
Yeah. Cool. So let's do that, and let's see what happens. So now it should be going forward, like where the nose of this thing is pointing. So it's pointing up a little bit, like so, and then let's place it with happens. Whoa! Where did it go?
How fast is it?
Oh my god, it's like... it's like fucking... It's fucking going. Okay, that was weird. By the way, you can type F in the editor. So if you select an actor and you hit F, it will zoom to the actor. So it's very, very life-saving. If you end up really far away, then you can use F to get to one specific actor. Very nice. So I think I know what's going wrong. It's like zooming off somewhere. Oh, there it is. I'm coming! I'm coming! It's okay, there's a way! Okay, so anyways. What I think is happening is that the mesh still has collision, right? So the mesh has collision, hash collision, and the sphere has collision. And these two are intersecting all the time. So what I suspect is happening, unless I'm completely wrong, is that it's detecting that the sphere is inside of another collider, so we'll try to depenetrate out of it. And then, you know, but since it's attached to the sphere, it will just move with it, and then we'll try to depenetrate again, and we'll try to depenetrate again, and then it just like zooms off from the depenetration. So I think if we turn off collision of the mesh, let's do it in Blueprint first, just to sort of see how that works. We go into collision settings on the mesh. So I want to turn off collision on the mesh. I'll go into collision settings. And then here on collision presets, in collision settings, right now it's set on block all dynamic. So that's just one of the blocking types of collision. You can see there's a bunch of collision profiles here. There's like UI, vehicle, trigger, ragdoll. It's insane. But this one is one we want. We want no collision, so we want to turn off collision completely. We don't want this to react to collision at all. So I'm setting this to no collision as a collision preset. And hopefully, now if I play, it shouldn't just zoom off into space. Okay, it's still dead. Where'd it go? Oh, there it is. Okay, so it's still fucking... it still ran off. Okay, so that means I've done something else wrong, and I think it's... I need to restart. Let's restart. I think I've done too much. I've flown too close to the sun. Don't care. Alright. So let's see. Okay, so let's place out a projectile now. Oh, whoops. There it is. So you have a projectile, and now maybe it will behave if I play. Ah, there we go. Okay, so it was just a restart editor kind of thing. Bye bye. Okay, so it's going a little bit fast, so let's bring it down a little bit. I'm gonna put the projectile movement in code in a little bit. I just wanted to hear now because it's much easier to look over the settings and sort of tweak things. So I'm doing it like sort of prototyping in Blueprint for a little bit, and then we'll put it in code. So just the 600 just so it goes a little bit slower, so we can see what's happening. There we go. Yeah, okay. So first of all, it's going through the floor, right? So as it hits the floor, it just goes right through. Can anyone guess why this is happening?
It's because the collision preset is set to what was it? Overlap instead of block
On what?
on the sphere.
Oh, that's very good. Good catch. Why did it work before?
Because we had the mesh set to block.
Yes, because before the mesh was the root component, and then we had block all. while a sphere component by default has overlap all. So that means it's just gonna overlap with whatever and just move through the ground. So very
But
good. Sorry.
Then it wouldn't collide with itself, right?
No. So I was probably wrong in that. That was a wrong. Guess.
Just making sure.
Yes. So no, it would not actually try to depenetrate with the mesh because this is on overlap all. So I'm just gonna do block all instead. Actually, let's do block all dynamic. Difference is subtle. We'll talk about that later when we go into like collision, like all of this shit. It's like, oh god, get it away. Okay, there we go. So this is like the collision matrix, and that's, you've probably seen this in Unity if you worked with collision stuff like that. They have this very similar to how it works in Unreal. It's just that you can also set the collision matrix individually on each actor. But we'll talk about that some other time, not today. So let's do block all dynamic. So now, whoops. If we play, there we go. It hits the ground and it just lands and it just stops. Great. Cool. We can probably also make it so if I do here, there was I saw a cool bool that I wanted to try out here. Rotation follows velocity. If true, this projectile will have its rotation updated each frame to match the direction of its velocity. So that seems pretty cool since we have like cone-shaped thing. So I'm just gonna set that to true. So let's see what happens then. Nice. Now it actually like points towards where it's going. Very neat. I don't know why I have so much fun with this. Anyways, so that's what I usually do. I think this is a good exercise to how, if I was working at at Hazelight and for some reason I wanted to use a component in Unreal or I wanted to use a component that someone else made or something. Again, I would probably make it in Blueprint first. I would go into Blueprints. It's easier to reparent things. I could change collision profiles very easily. I can, move things around. I can tweak values. I see them very easily. Easy to test. Drag a value around, play. Drag a value around, play. It's much faster. And then when I feel confident that this is what I want to do, this is what I want to use, it feels pretty good, then I would start moving it into code. And I would, start over when I know what I'm doing. I know which values I want to tweak. I know this is the tools I want to use. And so on. So yeah, I think this is very useful to do. I think it sort of speeds up your learning a lot, and it also makes you more comfortable with the environment you're supposed to be working with. It makes you more comfortable with working with blueprints. You get a better feel for the engine, and so on. Let's take a quick break because someone's calling me. So let's break 5 or 10 minutes, and then we'll do just the last couple, maybe 40 minutes or so, and then we'll call it a day. So see you guys soon. What up, pals? Peps.
Boo.
Actually, I just remember that I was recording through all the breaks, so I hope it doesn't show up when I was shooting Dookie earlier. Maybe I should cut out the breaks. Hear me dropping off the kids at the pool. To check that out. Are you guys ready to start? Maybe we should type in the little thingy.
Yes.
Let's continue. Wee woo. All right. So we were prototyping our projectile a little bit in blueprints. So yeah, let's say we decided that projectile movement was dumb. We don't want to use it. It's over bloated. We want to do it ourselves because maybe we have some features that it doesn't have. So I'm gonna say like, no, fuck you. Thank you, Unreal, for providing nice functions, but no, I want to make it myself because we're fucking coders. We don't need to be held-handed. So let's start doing that because I think that will be very very helpful for us to actually do that journey. So yeah, let's remove the projectile movement here. So we'll keep the sphere and mesh because those are good. So we'll keep those, but we'll sort of skip the projectile movement part, and that movement part we will actually make ourselves. Right. So I think it makes sense to first of all define how to move this little man. So I will make a tick function actually. Vic. So I'll make a tick. And do you guys remember how we would move our actor with like a delta? You guys remember?
You mean delta time, right?
Well, like a delta offset, like if
Oh.
we did.
Fuck.
You guys remember? It was yesterday.
Like add actor world offset. Something?
Yes, there we go. That's what I wanted. Add actor. We can also do local, but let's do world because we're fucking sick. So I'm gonna do add actor world offset, and then delta location. So let's say we want to move. Let's say we make a. Let's say we want to move forwards. Yeah, let's just do that. So we'll do get actor forward vector times. Let's say it's some speed 500. Like so. We're coders, so we know what we're doing. That's gonna work great, right, guys? Right?
No.
That's gonna work? No? You don't think it's gonna work?
It's gonna work, but not great.
I don't think it's gonna work just fine. I think there's nothing wrong with doing that, actually. So let's see what happens. It's just gonna hit this
5
wall.
meters per frame is gonna be fun.
Woo! And there it goes. Bye-bye. Wait, there it is. Why aren't you going? You're supposed to be going! Okay, so it's not going.
But
why isn't it going?
It's going so fast that it's standing still.
Yeah, it's like looping around the world.
It's supposed to active tick.
Sorry, what did you say?
Don't you need to say that it's going to activate tick?
Yes, very good catch. Do you guys remember how to do that? We never actually wrote that code, and I think it's good that now we actually have to write that code ourselves, because that will make us remember. So you guys remember what the code was to say that this actor is even able to tick?
Was it primary actor tick something?
Yes.
That's the truth.
Primary actor tick.
B can ever tick.
Can ever tick. Very good. So this is telling Unreal that this class can even be considered for ticking. So we'll add it to like a global tick list. If this was false, it wouldn't even be in the list.
When I looked at it though, it said that it had a default value of 1, so I'm assuming that means it's true by default.
Ah, okay, yeah. That's okay. So this one is weird. This :1. Does anyone know what this :1 does?
I've never seen that.
Sorry?
Something to do with the bytes.
Yes. So remember we had this discussion last in the beginning. I said like, oh, a boolean is 1 byte. There is an exception to that, and this is the exception. By doing :1, you're telling C++ that this is actually a 1-bit value. You're saying this uint will only take up 1 bit. So this is the only exception to that rule. And it's kind of, it's kind of tricky what that means. Well, what's happening is that it's sort of analyzing each these in a row and seeing that, okay, this one takes 1 bit, this one takes 1 bit, this one takes 1 bit, it's 6 of them. And it will make a bit mask for these ones that's 1 byte big. So it will compile all of these bools, and if there's more, if there's like 16, then it will make a 2-byte variable, a 2-byte bit mask to contain all of those ints, or all of these booleans, or whatever you want to do. And you can do any combination. You can say like, oh, I want this to be 1 bit, and this one should be 2 bits, and this one should be 5, and it will just sort of squish those together into a bit mask, or it will just sort of do whatever magic it needs to do to make that happen. It's almost only used when either making bit masks like this. So this is like making a bit mask but nice, so you can reference each bit by its name. That's when it's used. It's also sometimes used, for example, if I go into the Win API and I say like, oh, I want to check out the mouse down event. So here VML mouse button down. What we'll see here. Oh, that's not the mouse. Let's do key down actually. Let's do key down. There. What you see here, lparam. So that's I think it's a long. Yeah, it's a long. So it's an integer. Here they are defining that different parts of the byte, or sorry, of the integer are sort of mapped to different values. So here they're saying bit 0 to 15 is the repeat count. And then bit 16 to 23, that's the scan code. And then 24, this is 1 bit, and that's just if it's extended. And these bits are not used, and then 29 means something, and then 30 and 31. So they're mapping different bits to different things. Like it's not like here's 1 byte that means this thing, here's 1 byte that means another thing, and so on. They're actually sort of taking one integer and splitting that up. And here you would also use these size modifiers. So you would say you would make 1 byte that's 16 bits big, and then you would make one that's what is this, like 7 or something? I think it's 7 bits. So you make one that's 7 bits, and then one that's 1 bit, and this one is 3 bits. And so you would map these values to those bits, and then you could reference only those bits by name in a very convenient way.
So that is a language feature.
It's a language feature, yes.
Cool.
So if you're doing this, do you need to also pad like the rest of it so it can fit inside of the 8 like the 8-bit it's supposed to be 8-bit for addressing, right?
Yes.
Do you need to pad it out so it's like either 8 or 16 or 24 or whatever?
Very good question. Very good question. It does that automatically. So
cool.
It will on its own pad the byte, so it's in a byte boundary. Boundary.
Yeah. Awesome.
And it will actually be a 32-byte boundary. For performance reasons, all classes and structs are always in 8-byte chunks, which means that if you make a byte and then an integer, so if I have a struct here that's like, this has nothing to do with this, but this is interesting, so I like talking about it. If you make a loose struct here and I make it like a byte A and an int B, if you naively think about it, if you was like, okay, how should this look in memory? Then, I would say maybe it would be 1 byte would be A then, and then it would be 4 bytes with B. Something like this, so the class would be 5 bytes big. But actually, for performance reasons, they want to keep members in 4-byte blocks. So what would probably happen here is that it would actually pad this A member to be 4 bytes long. So it will actually do A and then pad, and then B. So that the member B is in a 4-byte block. And this is called structure padding. It is something that C++ does.
I think from C++11 you can do that manually also after the struct name, after Lou. I think you could also put how big, like if you want it to be 16 bytes, you can put 16 there, I think, and it will fill it out to be 16.
Oh yeah, I can maybe do something. I know it's Pragma Pack before, at least. It was like Pragma Pack, and then you set like 0 or push or something. I don't quite quite remember how you write it because I've done it so seldom. But you can turn it off with a Pragma like this, and then you would do Pragma Pop. So yeah, you can define, like, if this is supposed to be a net message, for example, like you wanna send a struct over network, you don't want this padding, obviously, because you don't want to waste bytes. You don't care that there's a performance loss, you want to get rid of them. Then you would say, like, okay, this struct that I'm making, don't pad it. I want it to be as small as possible. So that's called structure padding. So that's quite interesting. It can sort of throw you for a loop sometimes, where you do like a size of a struct and it's bigger than you think it should be, and that's probably because it's been padded. So, you know, not something you need to remember, but it was just an interesting tangent that I think is very cool. But yeah, okay. So B can never tick. It's a size 1 bool that is set to false by default. So if we play now, I haven't compiled, so gotta do that. There we go. Let's play. Boom! There it goes. Bye-bye. So what would we do to make it not go at 1 billion? What would we... To turn it from doing 500 units per frame, how do we turn that into 500 units per second? How do we do that?
Say it together now, everyone.
Delta
time.
Delta time.
Yeah, so we go times delta time there. So that will turn it from units per frame into units per second. I didn't compile it, so excuse me. I got so surprised. That
one was impressive. There was effort behind it.
Oh dear. Okay, there it goes. Cool. All right. So now we have it moving, but of course we wanted to stop when it hits something, maybe to bounce or maybe to just destroy itself. Do you guys have any idea of how we would do that? How would we make it like stop at the wall?
Ooh, there was
You add true after this. They add on the world offset.
What does that do?
It then sweeps.
It will then sweep, right? And what does sweep do? Can anyone explain sweep to me in simple terms?
It checks before it moves if it's going to collide or not.
And what happens if it does collide? What does it do then?
Magic.
Magic?
We can select what it does.
You can select what it does?
Well, we can add things to it, but it will stop if it hits something.
Yes, there we go. It will stop at the colliding points. Very good. So we'll just do true here. So that means bool B sweep is false, and I will set it true.
So it calls that function, but only if it's not collided yet.
It calls a function?
Or the move, what was it called? Set, offset something. Yeah.
Hmm?
Add the actor world offset. So what the sweep does is it adds the world offset until it collides, right?
Yes.
So and then it stops doing that unless we tell it to do something else?
Well, it would always do that. The only way we can change this is by looking at the hit result and then doing something else based on that. But the sweep will always take it up to the hit, and then that's stopped there. So.
But if we do something like if we check if if it's a hit, then we can redirect somewhere else, and then it will continue doing stuff.
Yes. So then we can react on the hit and do something cool.
Yeah, makes sense.
So let's see what happens now. So it will move and boop. And it hits the wall. Let's actually set the collision profile. I kind of cheated a little bit by setting the collision profile here in the blueprints. Let's actually reset that just so we can see how that's done. I would probably do it in blueprint anyway, because you have access to the matrix in an easy way. It's much more visual. It's kind of a nightmare to do collision presets in code, but I think it's a good learning moment to actually do it once to just sort of see how it's done. Kind of like with the asset referencing, I would never do it, but it's always good to know how to do it. So now,
kind of follow-up question about
what's gonna happen? Wait, first, before your question, what's gonna happen? Is pulse?
It's gonna go straight through the wall.
Why is that?
Because it's no longer blocking.
What is it instead?
Overlapping.
The equivalent of a unity trigger.
Okay, good guess. Let's see what happens. Ah, very good. It goes through. And why doesn't it block though? We have a mesh here, right? And it's block all dynamics. So why didn't it stop? Because we have a blocking volume, right? Or a blocking collision on our actor. You guys remember this?
Guessing it only checks the root.
Yes, very good. It only checks the root component when it sweeps. Very good. Okay, sorry. What was your question?
Yeah, so like now we're basically recreating the like projectile physics thing. Would you do this if you were actually working on it, or if you knew that you want exactly that functionality? Would you recreate it in C++, or would you just do it in Blueprint and keep it at that?
It depends. If it's like a turret that is like in one level, that is like a sort of like a little level thing, I would probably do it in Blueprints, honestly. I always be like, oh, it's supposed to follow the player for a little bit and explode or something. I would probably do that in Blueprints. If it's like a player projectile, then I would probably do it in C++. If it's like that is supposed to be the whole game, is supposed to be this projectile and it's supposed to do cool things, then I would probably do it in C++. But it's hard to say, really. It will depend on the situation. So that's a good question.
Makes sense.
Very good.
Is that because you get more control over how it functions, I guess?
It's easier to change. It's easier to grow. So if it's the player projectile, it's sort of, it's sort of cursed that it's gonna grow in size, like it's gonna become big. I'm gonna have to reference it from the player gun. That's probably the biggest point, honestly. That it's like I have to reference it on the player gun. Then it's easier if it's just in code as well, so I can put functions in code and call those. But also, like, if it has to be refactored, if it has to be remade, moved around, if it grows a lot, then it's easier to manage that in code. So I'm sort of predicting. But I wouldn't. If someone was like, "Oh, I will make a blueprint," I would be like, "That's fine as well." That's like, it's not really. I wouldn't say it's like, "No, you have to make the code because." I would just be like, "Okay, yeah, that's fine as well." But I would probably do it in code. But
cool.
Both are totally fine. Yeah. Okay. So it's overlap, and that's no good. So we want to change it in code to be block all dynamic. So how we do that is, I don't remember, but we're gonna find out together. We'll do set collision profile name. There we go. So here we have set collision profile name. So these are all preset profiles. So here's collision presets. So in project settings, there should be like a collision here. Yeah, here it is. So here is a bunch of collision settings that have been created by the editor already. And they are referenced by name. And then if I double click them, here is like the preset collision matrix for that profile. And just like with inputs, we can reference those presets by name. So we will reference this collision profile by just typing in its name. So in this case, the profile is block all. Or actually, we want block all dynamic. We want this collision profile. So we will just reference that by name. So we call this set collision profile name and then text block all dynamic. And similarly for the mesh, we want to turn off collision there. So I will, in the same way, I will reference the no collision profile by name. So I will do set collision profile name and then text no collision, like so. So now we've turned on blocking for sphere and we've turned off collision for the mesh. So even though the mesh collision didn't actually affect us very much, it's always good practice to turn off as much collision as you can, to only have like very controlled things colliding with things. There we go. And let's see what happens in Blueprint. I'll just double check. Okay, so this is set to overlap all dynamic now, but there is a reset to default here. So what's happening is I've saved this where overlap all dynamic became like an override. So now when it was changed in code, it actually didn't get changed just because this was mapped as an override. But if I hit this reset here, it should go to block all dynamic. So I'm clearing that override. So it's just faultily assumed that I was overriding as overlap. And the same thing with the mesh. It's assuming I override it. Don't know the word. I overrid it with block all dynamic. Same thing there. We want to reset to default, and that's gonna be no collision. Whoops. So I'm gonna save. And now, let's see, does it stop? Ah, yes it does. Cool. So now it stops properly because the sphere has blocking collision. Great. Fantastic.
Were you going to explain the difference between block all and block all dynamic? Or is that too much right now?
Nah, let's do it some other time.
Okay.
It's not super interesting, I think. Okay, so let's make it arc as well as the final thing we'll do today. So we'll make it arc nicely, and then we'll call it a day, and then we'll continue tomorrow. So right now, if I move it upwards, then it just keeps going, right? But I wanted to actually like arc downwards with gravity. So the first thing I'll do is just save velocity separately. So I'll just make a velocity variable here. And then on begin play, let's add begin play. When is begin play called?
When you spawn the object, right? It's the equivalent of awake in Unity.
Exactly. So in begin play, we will set the velocity to be get actor forward vector times 500. And then I'll replace this hard code 500 actor forward vector. I'll replace that with velocity. Oops, that's not how you spell that. There we go. And how would we add gravity to this?
Is there a magic function, or do we just do it ourselves?
It probably is a magic function, but we're gonna do it ourselves because we're fucking sick. How would you do it?
Z is up, so we'd have to take negative 9.8-ish multiplied by delta time, and then add that to velocity every frame.
Okay, so so let's see. Okay, velocity. Let's do minus equals. What would you write?
It's called an F vector, isn't it? And then it's 0, 0, 9.8.
9.8.
Wait,
I'm assuming it's in meters, is it not?
No, it's centimeters.
Oh, damn.
So it would be 908, right? 980.
Yeah.
Okay, that's it.
No, because we need to change the velocity by delta time as well.
Right, because what is this? What is the unit
meters
of this right now? What's the unit of this force?
Centimeters per second.
Well, what's the unit right now as it's written right now? What's the unit?
Oh, that's in centimeters per second.
No, that's we're applying it.
Per frame.
Per frame,
Yeah.
there we go. That's the unit. We're doing 980 units per frame. And we want to convert that to...
Per second?
Per second.
But you're already converting it to with the delta time when you're applying it.
What do you mean?
Yeah, but no, gravity is an acceleration, not a velocity, so it's going to be multiplied again. So we do multiply by delta time.
So we're adding a force So when we add a force, we want to add a force per second. And this is separate. When we're applying the velocity, we also want to apply the velocity per second. So that's where like the per second part is coming in, because we're doing like sort of the double delta time thingy. But yeah, so we want this to be times delta time, because the force is a force per second. So now we're applying velocity as 980 per second. And let's see what happens.
Did you recompile it?
Nope. It's going off into space. I love the gizmo is being reflected here. It's like fucking. It's like, wait, is this real life? Okay.
Looks really cool though.
Yeah, it looks sick. Okay, so there we go. And hello. I think it's angry. So let's just recompile. Let's just restart. We went too far. 1 step 2. I see like the face palms every time I restart this. Like, are you fucking serious? We have to do this. It's like, hell yes, we have to do this.
It's gonna be so fun when we start with the project.
Yeah, bro. Don't worry about that. It's just random and sure. Cool. Let's see. So it's in here. Blueprints. There we go. Fuck projectile. Put that in, and then rotate it upwards and play. And play.
Are you setting begin play?
And play. Oh yeah, okay, that's probably it, yeah. It's kind of weird that they're not warning me about that, but we're not calling the super of begin play. So when we override begin play, we did stuff, but there's actually important stuff going on in begin play for the actor. I don't exactly know what. I think it's registering. I'm pretty sure registering primary actor tick is in begin play, I would assume. So we have to make sure that we call the super version of begin play. And normally in C++, the way you do this is by doing a actor, like the name of the parent class, and then begin play. That's how you call the super version of a virtual function. Luckily, Unreal defines something called a super. So super is an alias for the parent class, so we can just do super colon begin play, and that will always just be the parent class. And if we actually go into actor begin play here, we can see that it does a bunch of stuff here. So here's register all actor tick functions. So this wasn't run, which means that our tick function was never registered, because we didn't call super begin play. Inheritance, it's never been a problem ever.
For me, it's also called super tick. What does that do? Is that important?
I don't know if super tick does anything actually. Let's check it out.
I just created a new, like, I think it was pawn.
Let's go.
No, it was just an actor, yeah. And it put that in.
Let's see what happens here. So if it has any file compiled from blueprints, in case we don't care about that, it seems like it's calling blueprint tick here. So that's kind of important.
Oh.
And then here, let's see, update any latent actions we have for this actor. Okay, so that's gonna be like delay and stuff like that. It's also gonna be processed here in actor. I didn't actually know that was happening here. So latent actions is stuff like delay and timeline and stuff like that. So that's also not going to be called if we don't call super. So very good catch. We should call super and tick as well. I think this is dumb, but okay, cool. So we have to call super there as well. So that's a good. Even though in this case we strictly don't need it, but it's it's good form.
Why was the projectile like going forwards before though? Was it because we hadn't overwritten begin play?
Yes.
So it was just okay. So then it was just calling super, I guess.
Yes, and so what was the crucial mistake that didn't make it go forwards by overriding super, by overriding begin play? What was the crucial thing that didn't happen?
What do you mean?
There was something in begin play that happened.
It didn't call super like we never did the ticks because we never said it to do it.
Well, what happened in super begin play that was crucial for us for a tick to function?
I registered the bool that we set in the constructor.
Yeah, it didn't register the tick function. So that was the
Yeah.
crucial mistake that
Oh.
happened when we overrid the gameplay. Which means
Right.
the tick never ran. Because it was never registered.
Cool.
So now, if we compile, it should work fine.
I'm assuming why this is also needed, as opposed to like update and awake and stuff in Unity. You don't need to have like the base class. I'm assuming that's because of reflection as well, right?
I think so, and also I think that the base class of
Mono behavior.
mono behavior, that it is. I don't think the base versions of those does anything. I think those are just called for the Unity implementations.
Are we
Yeah,
talking about
that's correct.
update or?
Yeah, update and
Yeah.
awake and all of those things. I don't think there is any base implementation of those in Unity, which is the way
No.
it should be. I'm angry that that's not the way it is here.
Yeah.
I hope it
Uh,
was like begin
and I
play.
think- They don't even use reflection, right? They use something else weird.
Really, because you don't have to override them either. You can just put them in and it just works.
Yeah, it's some Unity magic of some kind.
I'm
Yeah,
pretty
it's
sure
just,
they
it's
use
magic
reflection.
names.
Yeah,
It's just the name of the function is what it goes by. If that's all it needs.
I'm pretty sure it does reflection there, yeah, to check if you even have a tick. So if you don't have an update, it never considers the mono behavior a tickable, so it doesn't add it to the list. Whereas
But
here,
it's
we have to do
not
this.
really reflection. They do something else weird. I
they
read
do?
a like Unity article on that.
Oh.
I can see if I can find it.
Oh, that's interesting.
Yeah.
But yeah, magic, it's always magic in the end, right? Silver reflections is magic with a
Yeah.
name. Alright, cool. So now we're going downwards. So let's do one last thing before we call it a day, and I need to eat because I'm super hungry. So it's going downwards, so at least our gravity works fine. Let's make it so we're actually facing the velocity, because I like that. Since we have like a cone-shaped projectile here, it would be nice to have the cone actually point where we're supposed to be going. So in Unreal, to set rotations, we do something called set actor rotation. Like so. We could also do add actor world rotation. We could also add actor local rotation. All of those works as well. But in this case, we want to set the rotation to be like point towards where we're going. And it takes a quaternion, or it takes a... Hello? Oh, there we go. Or it takes an F rotator. And F rotator is just Euler angles. So we can either do it with F rotator, which is Euler angles, or we can do it with a quaternion. In this case, we want to have it point towards our velocity. I'm not sure how you would do that in Unity. I don't remember exactly what the function would be called. But in this case, there is a function called in fmath. So fmath is like the general mathematics library of Unreal. Like here is most of the very useful mathematics functions. So in fmath, there's gonna be something called make. Why am I not getting like autocomplete? Okay, well, whatever. It's gonna be make rot from x. So if I go in here and check it out, here is an F rotator, make rot from x. It actually might not even be in fmath. I think it might be somewhere else, but it's built a rotator given only a x-axis. I think it's supposed to be an x-axis, but okay, whatever. Right? It's an x-axis, right?
It is an x-axis.
Okay, well, whatever. Y and Z are unspecified, but will be orthonormal. That's a word. X-axis need not be X-axis need not be normalized. That's like the most fucking like science fiction. It's like when the Klingons are, you need not fire your lasers. You are already dead. So what this does is that it constructs a rotator where the x-axis of the rotator will be pointing towards this particular this vector here. So hopefully that kind of makes sense, that, you know, if we set an actor's rotator to be this rotator, it will have its x-axis pointing right towards the vector we put in here. So it's a very nice, very useful function that I use a lot to just sort of I want to point in some direction. Okay, then this is the perfect function for that.
Is there? It says that the Y and Z are unspecified. Is that actually unspecified, or can you make some guarantees that like Z will point somewhat upwards, or is it just going to be completely all over the place?
Very good question. Let's go in and check actually. Okay, well that doesn't help. But let's go in here. Okay, so here we can see what that assumption is. So make from X. Okay, so there's a bunch of stuff that we don't really need to care about. But the one thing we do care about it here, okay, new Y is doing, this is a cross product. So it's crossing up vector. And if we check, okay, what is up vector, then we can see that it's like, okay, it's doing whatever, but the important one is this one. It's choosing either 1 in Z or it's choosing 1 in X. And that is if the x-axis, here, if its Z component is less than 1 minus kinda small number. So kinda small numbers is defined to be like a small number. It's not small, but it's kinda small.
That's how you do it.
That's just the definition. So I'll just translate this for you. It's kind of mathematical jargon. But what this means is that if the x-axis that we're specifying to look towards is not Z, so if it's not straight upwards, then it's choosing just the Z-axis to be the up vector. And if it is pointing straight upwards, then it's choosing X to be the up vector. And what this means is that as long as we're sort of looking, slightly up and down, but still like roughly, like if you're looking at me and my head, as long as my head is pointing straight up, not straight upwards, but kind of straight upwards, then my eyes will be parallel, like they will be on a straight line. So as I'm looking up and down, my eyes are still level with each other. That's sort of the way you can process this. Is that it's pointing. My nose is pointing sort of forwards and up and down, but my head is always pointing roughly upwards. So my eyes are always roughly aligned with each other. So that's what the make from X function does. And then you have another, you have all the other variants where you can specify make from Y, you can make from Z, so you will make a rotator where the Z is pointing in a particular direction. And then if you want to really have control, here you have make from XY, where you can actually specify 2 axes to make the rotator from. So there you have more control. But it's fine. We don't need to worry about it right now. We only want to point the nose in this particular direction. So we'll use this make rot from X.
I have one more question.
Yeah.
There was, I assume, an overloaded operator for the cross product in that function.
Yes.
Do they also overload the dot product? And if so, what is it?
I think that's the pipe. Let's check it out. Oh, well. Is it in vector.h? Yeah, here it is. So the operator. So they have, let's see here. Divide, bit shift. Yeah, here it is. So here they've overloaded the up arrow, so that's the cross. And then here the pipe symbol is the dot. So
okay.
You can use those even though pretty much no one would understand what the fuck they're looking at. So I usually just use cross product.
Yeah,
and dot product.
they've got named versions, so I'm never going to use them. I just
yeah, but
in
it's
case I ever
interesting
see
to know. So that's when you see it, you're like, what the fuck?
Yeah.
XORing? What the fuck? But yeah, now it's just cross product. So yeah,
Okay,
we just want to make rot from X and X. So we want the nose to point in the direction of the velocity. So I'm just gonna pump in velocity here. And that's gonna make a F rotator. So that's gonna be our facing rotation.
I'm assuming it normalizes the vector internally.
Yes, so that's what the need not be normalized. That's what that means. That it will normalize it for you. So I will just type in velocity here. So that will make a facing rotation, and then we'll just set our actor rotation to be facing rotation. Facing. Let's see what happens. No, please. No. Okay, so I don't think it actually was in fmath. Okay, so there's actually like kind of two places where mathematical functions can be. Either they're in fmath, or I should have noticed when I alt-G'd that it was taking me to Kismet math library.
What's that mean? Like, why is it called that?
What do you say?
Why is it called Kismet's math library?
Oh, Kismet is the old name for blueprints. So in Unreal 3, their scripting language was called Kismet, and they just renamed it to blueprints. So when you see Kismet, that's just blueprints. So that's why. So if I scroll upwards here, I'm gonna find the name of this class, and it's gonna be. So here you can see there's like a polygon. Okay, it's a U Kismet math library. Okay, so that's what I want to call into them. So instead of fmath, I used to U Kismet math library. Whoop. Nope. Don't want to do that when I compile. Might have to include it as well. Yep. UKismet is not a class or namespace name. Okay, cool. So, can you guys find me? What's the include path for UKismet math library?
Kismet / Kismet math library, I believe. Let's find it.
Kismet math library.
Or slash, yeah.
That looks good. It seems like it
believe
works.
So.
Let's see what happens. Taking longer.
It failed
my
for me.
goodness!
Oh.
That's adorable. It's rotating because it's a sphere.
The rotation
It's
also when it
slowly rolling over.
kind of yikes.
Oh my goodness!
Maybe stop the rotation when it collides.
It be working.
Hey.
Why is it rotating further and further downwards when we're hitting the ground?
Because its velocity's still being changed every frame by gravity.
Yeah. And why
So
is it not? Why is the velocity doing that?
Well, we never actually told it to stop changing the velocity, right? We're just updating the velocity every frame, so now it's like some huge number.
Yeah.
It's just that our collider is repeatedly smashing into the floor every
Yeah.
frame.
It's just like smashing harder and harder down into the ground. So yeah, we probably want to do like if we hit it, then like set the velocity to 0 or something. So we can probably do like. How do I know if we hit something with the sweep? This will be the last thing we do, by the way. How do we know if it hits if the sweep is hitting something?
You wanna output it into a f hit result.
Yeah.
So create a f hit result before doing the add actor world offset.
Mm-hmm. And then.
And then after the boolean, you wanna have what is it? Reference hit. I don't remember the sign name.
Mm-hmm. It's a pointer to a hit result here, and that's going to be the alt sweep hit result. So it's a pointer. So we just pass in the address of this hit here.
Exactly.
But otherwise, yes, that's correctly. That's absolutely correct. Very good. So now we have the hit result, and we can check if we hit something. So if hit, hit be blocking hit. Then we might want to set like a velocity to be just 0. So I'll just do f vector and then just 0 like that. So I'm setting it to 2 is a 0 vector.
Wait, so if you just put one value, it will just copy it over all three?
I believe so. I'm actually gonna check because I'm scared. That's not the fucking right vector. Why is it going there? It's vector at h. I believe if we check the vector, colon vector. Oh, it's not here? Oh, crud.
Isn't it f vector?
Maybe it's up here, maybe? Okay, here it is. Here, f. Okay, so here's just with one scalar, and it constructs initializing all components to a single float value. So if you do an f vector with just one value, it will set all components to be that one value. So that's very useful sometimes.
Nice.
And now, okay, can anyone predict what's gonna happen?
I mean,
Isn't... Oh, go ahead.
no, you have something smarter to say. Go for it.
That would surprise me.
You're so nice.
Well, I mean, since we're setting the velocity to be 0, shouldn't the rotation go all wonky?
Good guess. Good guess.
Since we're using the velocity and not like the most recent like position delta or something like that.
I'm gonna counter that and say I think it's going to be consistent because we looked into the facing function and it was calling a function called getSafeNormal, which presumably will handle 0 vectors.
Oh, that's a good catch as well.
Yeah, I might have been a bit distracted while we were going through that.
I would still say though, I think wonky is a good word because it will definitely maybe not be what we expect to happen. So I would say wonky is maybe a good still way to look at that. It might be defined. It might be a defined wonky, but it will still be funky. So let's see what happens. Hey, I didn't compile. I'm always like bracing myself for what's gonna happen, and it's like, oh, nothing happened. Okay, let's go. Play. Hey.
Did you recompile?
Yeah, I did. Did I save?
I mean, aren't you now adding the offset, and then after you added the velocity, you set it to 0? You've already added the velocity, right?
Yeah, but it should be 0 after this point. Let's try again. I'm not.
Yeah,
I'm not
mine's behaving differently.
Yeah, I think maybe the compile has been. Oh, there we go. Okay, so there we go.
Yeah.
So definitely not what I would expect, right? I would expect to go down and stay in the same rotation, right? So I would call this wonky, but you are correct that it does check safe normal, and safe normal, if it can't calculate a normal because the vector is a 0 vector, it will just give 1 in x. So then the safe normal will give x, and it's pointing straight toward the x-axis. So really what we kind of want to do is that just, if we didn't hit something, if the velocity is not 0, that's when we want to set the actor rotation. So it's a very easy way to check if a velocity is almost 0. It's just the velocity is nearly 0. Like that.
Just question. What we're trying to do is make sure that the object stays in the rotation that is when it hits the ground, right?
Sorry, what did you say?
We're trying to make it so the projectile will freeze in the rotation it is when it hits the ground or collides with something, right?
Is that what was the question? Is that what we're trying to do, or?
Yeah.
Yes, that is what I'm expecting to happen.
Yeah. In that case, wouldn't you? It's called. I know. If make it so. Yeah, in statement checks if you hit the object, the wall, or whatever, then it should no longer set the rotation or so. Just leave it in the last one it was in. Because this it looks to me like where we continuously set the rotation even after it hits. We just and make sure the value stays the same. I was just wondering if I don't know if it was just better to not set the rotation anymore after it hits the object.
Yeah, we could do. I mean, yeah, probably an easier way to do this perhaps is to use. I think this is what the projectile movement does. Is that when we hit something, when we hit the ground, set velocity to 0, and then perhaps just do like set actor tick enabled to false, and then just return. That might actually be a cleaner way of doing this, honestly. To be like, we hit something, velocity 0, don't tick anymore, so don't move, and then just return. So this might be one way of doing it that's actually a little bit easier. So now it goes, and boom. So now it's not ticking anymore. So it just hit the ground, got stuck, and it doesn't update anything.
And if you wanted to keep updating for other things, then another way would be just to have a bool for checking if it has hit something, which you set to make your own bool and so.
Yeah, that would be another way of doing. If we block hit, then set some bool, and then use like don't do this if that bool is set, so then we can tick other things. That would definitely be another way of doing it. Cool, guys. I think we've gone long enough, so we got something to do next time tomorrow. We're gonna make it so we can actually shoot these bad boys, and then make them hit stuff and make them explode, and it will be carnage and fire. So yeah, I'll stay for a little bit just to do some questions if you guys have any. Otherwise, feel free to go and eat food and take a nap and do whatever you want to do. But otherwise, thank you very much for this lesson. I think it was very fun. You've been a great audience, and I will see you tomorrow. So, thank you.
Thank you.
Thanks a lot.
Thank
Bye.
you.
See you tomorrow.
Bye.
See you tomorrow.
Bye.
Thank you.
Bye.
Were you gonna post this project somewhere?
Oh, yeah, I forgot to do that yesterday, actually. So thank you for reminding
Well,
me.
Didn't go that far yesterday, but today I felt like there's some stuff I wanted to check in deeper.
I will do that right after this. I will zip this up and post it somewhere. So.
And this contains all the things we did yesterday as well, because I did think we went pretty far yesterday.
Yeah. This will be... do you want me to post yesterday's project as well, or just this one?
I would actually enjoy both of them, just because then I can jump in the first one and not be overwhelmed by all of this funky collision shit.
Yes, collision shit. That's what I usually refer to it as well. Yeah. Okay. Then I will do both. So I'll put both.
Thank you.
Good.
Will we have like assignments or stuff like that in this course as well later, or maybe just I don't know stuff to do like I don't know what's the word? Well, I guess assignments, but not graded or graded. I don't know.
I mean,
either.
exercises maybe.
Exercises.
Yeah.
That's the word I was
Exercises, yeah, and like labs and stuff.
Yeah.
Ideally, I want to have exercises. I think exercises are very good. Unfortunately, I'm not I'm doing this sort of as I go. I'm like I show up and I'm like I don't know what I'm gonna do today, so let's just do something. So I'm thinking if I can come up with good exercises, I will do them. So maybe on Thursday I won't be here. I will be working. So on Thursday I will try my best to come up with a good exercise to keep you guys going. Probably not new stuff. I'm just gonna do exercises that are like do what we've done, but maybe to change something up, just to give you guys a means to go over what we've done and try them yourself to make mistakes and figure stuff out. But I don't want it to be like you have to do this. If you don't do it, you will fall behind. I don't think that's the best way to do exercises.
Yeah, I think that's perfect.
So I will do my absolute best to have one. If there isn't one, I'm sorry. I is gonna come up with something. I will do my best. But I definitely think that it is a better course if there are exercises. So I will do my best.
Because I don't know. I take in a lot better if I'm just focusing on what you're doing, so I'm not writing at the same time. But then I also miss out on writing it myself, and then I miss out on that part. So going back and then doing it again is perfect. One thing Freya did in her courses, of course, comparing yourself to Freya might be hard because Freya is amazing, right? And you're awesome too. But setting the bar and stuff like that is that she went through a lot, and then she just came up with exercises based on the things that we've gone through. So just basically this is we went through this part of math, so we're gonna maybe you can do something with this. It doesn't have to be super detailed and stuff like that. I guess it's just in general, make this and do something that does this.
I mean, essentially all of our exercises could be solved by just watching the stream she did earlier, which was actually brilliant, because that meant okay, I don't understand this, what did she do? Oh, so that's what it means. And then you feel your third eye opening and you feel very smart.
Because then you go back and you absorb the information. It's perfect.
Absolutely. Yeah, it's a really good feedback and a really good idea. And I will take it into consideration and really think about giving you guys some exercises coming forward. So
awesome. Thanks.
Great.
Thank you.
It's been really good so far. I love it.
Thank you. You too.
All right. See you tomorrow.
Yeah. See you tomorrow.
See you tomorrow. Bye.
Bye bye.